Go ahead.
45, 45, so I did the formula for that, and then did the recording to it, because I times the square root of 2, and I divide by the square root of 2, and I split it on the table, and that's square root of 2.
Oh, 6 to the square root of 3. Awesome. Abby, tell us, do you agree or disagree?
I disagree.
How come?
Well, I think instead of putting it in the calculator, like, you work it out to where 6 is like 6 divided by the square root of 2, but you can't have the square root of 2 in the denominator, so you have to multiply itself by the square root of 2, and so you get 6 times the square root of 2 over 2, and after working that out, you get 3 times the square root.
Awesome, yeah. So that one, the 3 square roots of 2 would be the correct answer because you do 6 divided by the square root of 2. And anytime you divide by a radical, you cannot have the radical in the denominator. So you have to multiply them both by the square root of 2, and you get 6 square roots of 2 over 2. Okay. Now you want to check to see if you can simplify the whole numbers, the 6 and the 2, and you can. 6 over 2 is 3. Also, just a little kind of trick for you to use, just because hopefully some of you have noticed this already, and it's a really quick shortcut. On a 45, 45, 90 triangle, if they give you the leg, you multiply it by the square root of 2 to get the hypotenuse. If they give you the hypotenuse, you divide it by the square root of 2 to get the leg. Okay. So if they give you the leg, multiply it by the square root of 2. If they give you the hypotenuse, divide it by the square root of 2. And anytime you have to divide by the square root of 2, let's say it's x over the square root of 2, it's automatically going to be x square root of 2 over 2. So if I had 11 over the square root of 2, that's automatically 11 square roots of 2 over 2. Okay. If you had 12 over the square root of 2, that's automatically 12 square roots of 2 over 2. The only thing is 12 over 2 divides into 6, so you get 6 square roots of 2. Okay. So you can use this formula. Anytime you get this, you can use that formula. But if this number is even, go ahead and divide it. If it's odd, just leave it. But if it's even, divide it by 2. Okay. What questions do you have for me on the over here? Okay. Friday, you will have your Chapter 10 test. It'll be over sections 10.1, 10.2, 10.3. We're doing 10.3 today. We're going to do the notes today. You will have a worksheet over 10.2 as your homework assignment. And then we'll do an assignment tomorrow over 10.3, an assignment on Wednesday, we'll review on Thursday, and then our test will be on Friday. And then your final is next week. We will spend next week reviewing for the final, and there will be no going during.
Is it odd Wednesdays, even Thursdays?
I'm not completely sure. I have to look. So
you
odds
said something different, so I was looking.
Odds. Well, usually I haven't looked at it.
Because he said it's odds on Wednesday because they have to have grades in by that Friday.
Probably. And then evens on Thursday.
Mm-hmm.
Alright, we're starting 10.3, so you need your 10.3 notes out.
So if we have a 90% or above, we don't have to do the final
for the semester. Yep.
Will you let us know?
Yes, I'll let you know on Monday. Because I'll get your Chapter 10 test put in, and I will let you know your grade on Monday. You'll still need to take part in the review, but you just won't have to take the final. Okay, 10.3, trigonometric ratios. This was always, I don't know, for some reason, one of my favorite things in geometry is the trig ratios. Students will be able to use the sine, cosine, and tangent ratios. Alright, so first thing, I have this on your paper. because it helps you keep it in order. Is SOHCAHTOA. SOHCAHTOA. What this stands for is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, right now that seems very, very confusing, but as I show you exactly what that means, this will help you remember. Okay. All right. So first thing, you'll see this triangle on your paper. Okay. Now, your hypotenuse is always your hypotenuse. Did I write out your hypotenuse on your paper? Okay, so label your hypotenuse on your paper. No matter which angle you're referring to, your hypotenuse is always opposite the 90-degree angle. Okay, so label your hypotenuse on your paper, on your notes. Okay, now, determining which angle you're looking at. So right now, I want to look at angle A. Angle A. So I would put an arc on angle A to show that we're referring to angle A. Now, angle A, the side adjacent to angle A is the side right there next to it. So this side CA, that would be adjacent to angle A. Remember from like chapter 1, adjacent means next to. So this one is adjacent to angle A. And then this side over here, BC, that side's opposite to angle A. In which you already knew that from previous parts, from the previous chapters where we would say the side opposite the bigger angle is is the bigger side. Okay. So BC is opposite of angle A. CA is adjacent. Now, if you were to be looking at angle B, it would change. The side adjacent would be BC, and the side opposite would be CA. So it depends on which angle you're looking at, depends on which side's opposite and which side's adjacent. All right, so now let's go over the trig ratios. Sine, and I have this up here again, sine is opposite, and I'm going to abbreviate, over adjacent. I abbreviate. Oh, sorry. Well, it's opposite over hypotenuse. Sine is opposite over hypotenuse. See how it has OH, opposite over hypotenuse. Cosine is adjacent over hypotenuse. So cosine would be adjacent over hypotenuse. And tangent is opposite over adjacent. Now remember, it depends on which angle you're looking at. Okay, so if I'm looking at angle A, this side here is opposite, this side here is adjacent, and the hypotenuse never changes. It's always opposite the 90-degree angle. So if I was trying to find the sine of angle A, I would do BC over CA. If I was wanting cosine, I would do, well, I don't know why I keep saying that. If you're doing sine, you would do BC over BA, opposite over hypotenuse. Cosine is adjacent over hypotenuse, so cosine would be CA over BA, and tangent would be BC over CA. All right. Anyone need extra time to write those formulas down?
Would you count off if we like AC or BC?
You don't write the actual thing down, you write the number down.
Oh, there's always going to be numbers.
There's going to be numbers there. All right, teacher model. So I'll work this one out, and you'll just pay attention and write it down as I write it down. Find the sine, cosine, and tangent of S, angle S. So find sine of angle S, cosine of angle S, and tangent of angle S. Write your answer as a fraction and as a decimal rounded to 4 places. Now, as a fraction, you need to make sure that it's in simplest form. Okay, so first thing I'm going to do is write out the SOHCAHTOA to help me remember. And as you can see, I've already made a couple mistakes because I don't want to look at my thing. SOHCAHTOA. All right, so sine of S is going to be opposite over hypotenuse. Okay, so look at angle S. It's right here. The side opposite would be down here. The side adjacent would be here. And the hypotenuse is always the hypotenuse. The hypotenuse doesn't change. Okay? All right, so opposite is 63. Hypotenuse is 65. So 63 over 65. 6, 7, 8, 9. Yeah, these, I know 3 doesn't go into 65. 7 wouldn't be. Yeah, so this right here is already reduced. So 63 over 65 is already reduced. Then it says write it as a decimal to 4 places. So now you just type it in your calculator, 63 divided by 65. And the thing to be careful with here is to make sure you round correctly. Alright, so whenever I round this, it would be whenever I make the decimal, it would be approximately 0.9692. So that's sine of S. Okay. Now let's do cosine of angle S. Cosine of angle S is adjacent over hypotenuse. So look at angle S. The side adjacent would be 16, and the hypotenuse is 65. And let's make sure that that does not reduce, and it does not. And what would be the decimal? If I type in 16 divided by 65, I get approximately 0.2462, because the 5 makes the 1 round to a 2. Let me use a different color, 0.2462. All right, then the last one is tangent of angle S. Tangent is opposite over adjacent. Okay, so look at angle S. The opposite is 63. Adjacent is 16, and I'm pretty sure that does not reduce. No, it does not. And if I change that to a decimal, I get approximately 3.9375. And and that's not approximately, that's actually equal to, because I did not have to do any rounding. And there you go. I always do sine and cosine and tangent because notice it's 63 over 65, 16 over 65, and then tangent is just your first number over your your first numerator over your second numerator, 63 over 16, as long as you do it in the order of sine, cosine, tangent. Okay. Now, what questions do you have for me? Let's do one together. First thing I need you to do is fill in these missing numbers. You need to mark DE as 24, DF as 25, and EF as 7. Okay. So it wants me to find sine of D, cosine of D, and tangent of D. And I have to write my answer as a fraction and as a decimal rounded to 4 places. So first thing I recommend is writing out the SOHCAHTOA to keep you to remember it, to keep everything in order. Okay. Now they're talking about angle D. So next thing I would do is label which side's the hypotenuse, which side is adjacent, and which side is opposite. Which side would be my hypotenuse, Sydney?
Yeah.
BF would be the hypotenuse, perfect. What about the opposite side, Bailey? EF would be opposite. And what about the adjacent side, Maddie? DE, perfect. Oops, I used the same color. Let's use a different color. Okay. All right, so first we're going to do sine of angle D. Taylor, what is my formula for sine of D? Opposite over hypotenuse. Brett, what is the measure of the opposite side?
7.
Nick, what is my hypotenuse?
25.
Now my next question, can I redo 7 over 25, Grace? Say that again. No? Awesome. And Abby, what would that be to 4 decimal places?
0.28.
Oh, so I really didn't have to round. Okay, perfect.
Oh, so you don't add zeros to the end of it? It's like,
No. No, if there's nothing there, it should say rounded 4 decimal places if necessary. All right, let's do cosine of angle D. Natalie Brewitt, what is the formula for cosine? Perfect. And Lakin, what is my adjacent side? And Bolin, what would be my hypotenuse? And Natalie S, does that reduce? And what would that be to 4 decimal places?
0.26.
And the last one, let's do tangent of D. Tangent of D, what is the formula for tangent of D, Sydney?
Opposite over adjacent.
And Bailey, what would be my fraction that I put here?
7 over 24.
Maddie, can I do 7 over 24? And Maddie, what would that be to 4 decimal places? 2 point or 0.2?
Or 0.2.
Okay. And what number's behind that 6? Perfect. So it'll be 0.2917. All right. Now what questions do you have on it? Okay, so you can tell everyone that you were doing Trig today.
Woo. It's not that hard. Does it get harder?
It can get harder, like whenever you start going backwards and like they have a missing side and they give you the tangent, it can get harder. But I mean, I to me this is like the easiest concept from Trig. All right, it says find the sine, cosine, and tangent of a 45-degree angle. Notice there's no triangle, so the first thing I would recommend is that you draw a right triangle. Now it says a 45-degree angle. Well, if it's a 90 and this angle over here is 45 degrees, what's this angle over here going to be? 45 degrees. Well, don't we know something about these types of triangles? The sides are congruent. And remember our formula from earlier, from the previous section, like this side's 1, this side's 1, and the hypotenuse is always the square root of 2. Anytime you have a 45, 45, 90 triangle, it's 1, 1, square root of 2. And then every other triangle is just based off of the 1, 1, square root of 2. Okay, so anytime you have a 45, 45, 90, that's how you want to label it. Now, let's go through, remember SOHCAHTOA. So first, let's find sine of 45. On this one here, do you think it matters which of these two angles I'm going to look at? No, because they're both 45, so just pick one. I like picking the one on the bottom, just because I just do. Which side would be, and I'm going to label these A, B, and C just so you can tell me more easily which side is opposite and adjacent in the hypotenuse. Taylor, which side would be opposite of 45?
What is the AB?
So this side's opposite. Brett, which side would be adjacent?
PC.
And Nick, where's my hypotenuse?
Always across from the 90 degrees, so it would be the square root of 2.
Perfect. Okay. So sine of 45. Sine is opposite over hypotenuse. Opposite over hypotenuse. So Grace, what would be my fraction if it was opposite over hypotenuse? Opposite is 1. What's my hypotenuse? 1 over the square root of 2. Now, from the previous section, Abby, what's wrong with this fraction?
Well, the square root is in the denominator.
How do I simplify it?
You multiply it by itself.
Okay. So what's 1 times the square root of 2? And do I have to have that 1 in the front? So we just leave it as the square root of 2 over, what's the square root of 2 times the square root of 2? So there's your fraction. It's the square root of 2 over 2. And that does not tell me about making it a decimal. If it did, you would just divide those. You would do second square root of 2 divided by 2. And I got 0.7071. Okay. But they didn't tell me anything in here about rounding it to a decimal, so I'm going to leave it like that. All right. Okay, now let's do cosine of 45. Cosine of 45. Lakin, what's the formula for cosine of 45? Perfect. And Pruitt, what would be my adjacent over hypotenuse as a fraction?
1 square root 2 over square root 2.
Okay. What would it be before I simplified it?
1 times square root 2 over square root 2.
Well, it's just adjacent over hypotenuse. What's your adjacent side? 1 over your hypotenuse. What's your hypotenuse? Okay, so it'd just be 1 over the square root of 2. Now we need to simplify it. So 1 over the square root of 2. Natalie, yes. What would that be simplified? Perfect. So hopefully you get to where you see 1 over the square root of 2 and you're like, oh, that's just the square root of 2 over 2. Because remember, it's x times the square root of 2 over 2. And 1 times the square root of 2 is just square root of 2. All right, now let's do tangent of 45 degrees. Roland, what's the formula for tangent?
Opposite over adjacent.
Opposite over adjacent. So Sydney, what would that look like?
1 over 1.
And what does that reduce to?
1.
There you go. All right, we got one more directed practice problem, but before we move on, what questions do you have for me? Okay. one says, find the sine, cosine, and tangent of a 30-degree angle. Now, I have a right triangle, and this angle here is 30 degrees. What's this other angle over here going to be? 60 degrees. Now, have we seen a 30, 60, 90 triangle recently? Yes. Remember, their sides are 1, 2, 3. Start with the smallest side, which is opposite 30 degrees, and that's 1. And then your hypotenuse is 2, and your long leg is 3, but instead of it being 3, it's the square root of 3. So with 45, 45, 90, it's 1, 1, 2, but it's the square root of 2. With 30, 60, 90, it's 1, 2, 3, but it's the square root of 3. And your 1 is always across from your 30. Your 2 is your hypotenuse, and then the long leg is the square root of 3. All right, so we're looking at the 30-degree angle. So we're looking at this angle up here, depending on how you drew your triangle. All right, so what side is opposite the 30-degree angle, Bailey? The opposite. No, the opposite side. Which side is opposite of 30? Is opposite of the 30-degree angle?
The bottom.
The bottom one. Okay, this side here, that's a 1. Okay, perfect. So that side's opposite. Which side is adjacent to the 30-degree, Maddie? Perfect. And which side is my hypotenuse, Taylor?
2.
All right, so first let's do sine of 30. And we abbreviate sine S-I-N, so that's why you always just see sine of 30, S-I-N, equals, Nick, what would I make as my fraction? Oh, let me write my thing, SOHCAHTOA. What would my fraction be for the sine of 30 if it's opposite over hypotenuse?
It would be 1 over 2.
Anything I need to do to reduce that?
Nope.
Nope, it's done. What about for cosine of 30, Grace? And what would that look like? Anything I need to do to reduce that? Nope, there's nothing I can do. The radical's on the top, so I'm good. And the last one is tangent of 30. Abby, what would that look like?
It'd be opposite over adjacent.
Perfect.
So it'd be 1 over the square root of 3. And I will make it square root of 3 over 3.
Perfect. And how she got the square root of 3 over 3, she multiplied the bottom by the square root of 3 and the top by the square root of 3. 1 times the square root of 3 is just the square root of 3, and square root of 3 times square root of 3 is 3. So square root of 3 over 3. All right. Before you do your problem with your partner, and your partner's just going to be the person you're sitting beside, except for Nick. Nick, I'm going to have you come up here and sit beside Sydney. Y'all are going to be partners. What questions do you have for me? All right, here's your next one. First, you need to fill out the missing numbers. 24, 7, and 25. And it says find sine of f, cosine of f, and tangent of f. Write each answer as a fraction and as a decimal rounded to 4 places. Okay? All right, so go ahead and work that out with your partner.
Let me see what you got. Yeah, it should be 0.2. Yep, 40. Yes, yeah, because it was 39, so it'd make it round to 40.
We don't know how to round this goodness.
Hey, you can set your calculator to always round to the, how, like, you need it to round to the fourth decimal place.
How do you do that?
Go to mode. And see where it says float. Go down and go and select the fourth. Now, it will make all of yours go to 4 decimal places, so like, the point set 28, it would have 0.2800. But now go back to second hit. And type in 16 over 63.
It's magic.
Perfect. But you,
And now do 16 divided by.
Let's do this one here. What did you get for sign of our Bailey?
16 over 65.
16 over 65, and what was that as a decimal?
0.2462.
Is it approximately?
Yes.
Alright, what about cosine of our bowline?
Adjacent over the partners, and you get 63 over 65, and you get 0.692.
And Lakin, what about tangent of our?
16 over 65, you get 0.254.
And I would put 40 just to show that you rounded to 4 decimal places. Okay, now. Alright, now you're going to do the next two on your own. And here are the missing numbers, so go ahead and fill in your missing numbers. You got 15, 36, and 39 on the first one. And then 15, 36, and 39. And yes, you would need to draw the triangles. Okay? Alright, so these will be done on your own. Once you do these on your own and I check them, you have a homework assignment over section 10.2.